everyone. This is Zeenath Jaha Begum from MLR Institute of Technology, Department of Computer Science Engineering. So today I'm going to discuss about the one of the important topic of finite automata, that is automata and compiler design, that is types of finite automata. So in the previous class also we have discussed about the types of finite automata, and that we have discussed about actually there are two types of finite automata. One is the deterministic finite automata, other one is the non-deterministic finite automata. So in the last session we discussed about the deterministic finite automata, and also we have seen with some of the examples. So in the today's session we'll discuss about the second finite automata, that is nothing but a non-deterministic finite automata. So let's see with what is the definition for the non-deterministic finite automata and how it is different from the deterministic finite automata. Coming to the definition of the non-deterministic finite automata. So non-deterministic finite automata is a finite automata where you don't have any restrictions, and a state can have a null transition or it can have more than one transition. So that's why we say that non-deterministic finite automata is easy when we compare with the deterministic finite automata. That means the construction of the transition diagram is easy compared to the DFA. And if we say in the simple definition about the non-deterministic finite automata, the non-deterministic finite automata is the state where we can have epsilon transition or it can have more than one transition. Let's discuss about what is the formal definition of non-deterministic finite automata. So just like a DFA, here also we have a 5 tuples, that is capital Q, summation, Q naught, F and transition function, there is a transition symbol. So, but compared to the NFA and the DFA, these four are same, but transition function is different. Okay, different in NFA as well as DFA. So in DFA, generally the transition function is Q into summation tends to capital Q, whereas in NFA is Q into summation tends to 2 power Q. That means here whatever the output state which we are getting, it is exactly the 1, but here it can be 1, it can be 0 or it can be more than 1. So that's why we have written as 2 power Q. Now coming to the graphical representation of non-deterministic finite automata, these are the 4 points which we need to concentrate whenever we are designing the transition diagram. The first thing that is that the state is always represented with the vertices. The second thing is that the arc labeled with the input character, it always shows the transition function. And third one, the initial state will be recognized or marked as arrow, that is this one, and the final state will be represented by the double circle. So it is similar to the deterministic finite automata. Everything is similar, only the transition function will be different. And when we compare with NFA and DFA, NFA construction is very easy. So let's see with some of the examples here. So here the example is given here. It is given with the Q with 3 states. Input symbol is 0, 1. Q naught is the initial state as well as F is the final state. Okay. So whenever we draw the NFA, here we have to take a 3 state with the input 0, 1. And as I already told you in the previous discussion that NFA don't have any restrictions. That means the diagram which is there, that is also correct, and the diagram which I draw, that is also correct. How it is correct? This is also NFA. So why it is NFA? Because as I told you that each and NFA don't have any restrictions. That means each and every state can have either 0 transition, 0 is nothing but null transition, or it can have more than one transition. So if you can see here, Q0 have the transition with the input symbol 0 and 1. Q1 has a transition only with the 1, not with the 0. That is also acceptable. Q2 have the transition with the 1 but not 0. That is also acceptable. Right? But the same thing if we draw in the DFA, that is not acceptable. So in the DFA, each and every state should have exactly one transition from the input. So for the above diagram, whatever the above diagram, for this diagram, transition table. So transition table, how the transition table consists of? The transition table consists of present state, next input, that is a 0, next state input, that is a 1. For example, if in your question, if the input symbols are small a comma b, so here you can take a, here you can take b. Now, how many states are there in given question? 3 states. What are that? Q0, Q1, Q2. Q0 what? Initial state. What is Q2? Final state. Either it can represent with the star or simply you can give a double circle also for the final state. Now, Q0 to 0. Where Q0 to 0 is going? Q0 as well as Q0 to 0 is going to Q1. Here, Q0, Q1. You can see here more than one state. In the same way, Q0 to 1, where it is going? Q1. Q0 to 1, where it is going? Q1. Q1 to 0, where it is going? Q2. Again, Q1 to 1, where it is going? Q1 to 1, it is going. Is it going? Yes, where? Q0. See here, Q0. Next. Q2 of 0. Q2 of 0 is Q2 itself. Here we have got. And Q2 of 1. Q2 of 1 is 1 Q2. Another one is Q1. So we can write it as Q1 comma Q2. So this is the transition table for the above transition diagram. In the same way, the transition function is also very easy. That is, for example, Q0 of 0. What is Q0 of 0? Q0 comma Q1. Q0 of 1. What is Q0 of 1? Q1. Transition of Q1 of 0, Q2. Transition of Q1 of 1, Q0. In the same way. Transition Q2 of 0, Q2. Transition of Q2 of 1, Q1, Q2. This is the one. The next one we'll see with one more example. That is NFA with the input symbol 0, and which 1, which accept all string with 0, 1. Okay. So one more important thing is that here you know how to write the language. So directly there is a solution, but you have to know how to write the language. So what is the condition given here? The condition is given here. The string should accept with 0, 1. That means it should accept only 0, 1, not other than. So what will be the language for that? Simply 0, 1. That means Q0 0, Q1 1. And that means whatever the string is there, it can be 0, 1. And we can say that like this also. We can say like this also, so on. That means what? In the simple way, we can say that whatever the string you are taking, the string should accept a 0, 1 in any format. Like it can be 0, 1, 0, 1, it can be 0, 1, 0, 1, so on. So on it should be. But every time, whenever you write a string, the string should be 0, 1 only. Right? So now, as the minimum length of the string is 2, so how many states we have to take? We have to take 3 states, that is n plus 1. So 2 plus 1 is nothing but 3 states. So here it is given with the 3 states. So for the following given diagram, there is a transition table. This is the transition table, right? So you can see here Q0 to 1. So Q0 to 1. We don't have Q0 to 1. So simply we can put a dash or epsilon also, one the same. So we'll put a dash only here, dash. So here also Q1 of 0 is nothing there. So simply we put a dash. In the same way, Q2 of 0 is 0, Q2 of 1 is Q2. Okay, we'll see with the next example here. Design an NFA for the transition table given below. So transition here, the diagram is given here, right? So for the given transition diagram, what here you have to do it? Here you have to draw the transition table. So here, how many states are there here? If you can see here, here we have 4 states. So for the given transition diagram, you have to draw transition table for that. So transition table consists of what? States, that is the present states. Inputs, what are the inputs we have? 0 and 1. So if you can see here, how many states we have? Q0, right? That is the initial state. Q1, Q2, Q3. That's it. Q3. What is Q3? Q3 is the final state. So we have to draw the transition table for that. Now Q0 of 0. Q0 of 0 is what you can see. Q0 as well as Q1. Q1 of 1 is what? Q0 of 1 is what? Q0 itself. In the same way, Q1 of 0, is there Q1 of 0? Nothing, dash. Q1 of, yes, Q1 of 0 we have Q3. Now Q1 of 1, do we have Q1 of 1? No, then you can put simply dash. Next, Q2 of 0. Q2 of 0 is Q2 as well as it's going to Q3 also. Q2 of 1. Q2 of 1 is Q3. Next, Q3 of 0. So Q3 of 0 is Q3 itself as well as Q3 of 1 is also Q3 itself. And one more thing here, Q0 of 1 is Q0 as well as Q2 also. So this is the transition table for the above transition diagram. So by this, we can able to construct the transition. In the question, if it is given with the conditions, we can write with the language. We can draw the transition diagram. So once the transition diagram is clear, we can go for the transition table as well as the transition function. So this is now the topic which we are covered in the today's session. So hope you understand the today's session. So types of finite automata we discussed in the last session. So in that we discuss about the deterministic finite automata, and in the today's session we discuss about the non-deterministic finite automata with the example. So in the next class we discuss about the conversion of the NFA to DFA.